Hello, everybody. Aging is what I'm going to talk about. The next 100 years of aging. What will it look like? Well, for one, my biggest fear is that our bodies are living longer and longer, but our brains still have the same short half-life. Is anyone else afraid of that? A couple people. I don't see David, but his hand's probably up. So in the next 5 minutes, we're living longer. This is the path we're on. You can see the rate of Alzheimer's going up and up as people are living longer. This is in direct correlation. But in the next 5 minutes, I'm hoping to convince you that we may be able to avert that path, able to treat brain disorders by refocusing what we're looking at, and treat other disorders of aging by looking not just at human proteins, but as many people have referred to tonight, but at the bacteria, the microbiome living within us. So I'll tell you a little bit about my own story, and then we'll talk about the broader, how that relates to the broader research. So to set the stage, I'd like to talk about this Australian physician and researcher named Barry Marshall. In 1982, he and his collaborator Robin Warren discovered that the bacteria H. pylori could be cultured from and was a likely cause of ulcers. And this was met with extreme skepticism from the establishment because everybody knows that ulcers are caused by spicy food and stress. In 1984, he went so far as to drink a petri dish of the bacteria to prove his case. He got various GI symptoms, and in 2005, the pair was awarded the Nobel Prize for this discovery, and ulcers are now treated with antibiotics. So this was a long path to prove his case. This is Dr. Stephen Dominy. He's a UCSF psychiatrist with a specialization in HIV dementia. So he knew pathogens can cause brain disorders. What other pathogens might be causing brain disorders? And monitoring the literature, learning about bacteria that live in our bodies, pathogenic bacteria. And he called me in June 2013 and said, I think I've found a bacterial cause of Alzheimer's disease. My name's Casey Lynch. I'm an entrepreneur with a background in Alzheimer's research, so I was very intrigued. Like many others, I've been frustrated by the string of failures of A-beta targeted therapy. So A-beta has been the focus of billions and billions of dollars and a huge amount of research. Really 95% of the money has gone into this target, but most of the studies are failing. So I was excited about a novel approach. This is what Steve showed me. For those of you not used to looking at brain sections, these are neurons, and they've been stained for a toxic bacterial protein. This bacteria actually secretes enzymes which literally digest our cells for food. And this brown staining is showing that. Also, what you can see here is these neurons are not very happy. They are falling apart. So in a normal human, we don't see this staining. But we all know that the difference between correlation and causation, just because these bacterial proteases are in human brains, does not mean that they're causing Alzheimer's disease. So we set out to do a number of experiments to prove to ourselves and the rest of the community that this was indeed a credible theory and that we could develop treatments targeting it. The first thing we did is look at as many human brains as we could get our hands on. So far we've looked at 43 Alzheimer's patients. Every single one of them has this bacterial protease in their brain. We've looked at 30 preclinical cases, so these are people with pathology, but they're not diagnosed yet. They also have it in their brain, every one of them. In normal people, healthy people, some people are clean, but some people do have small levels of this bacteria and its proteases. So we think those people are on a path either to Alzheimer's or maybe they just look like accelerated aging. We don't know yet. The other thing we did to prove causation is to infect mice. So this is just a peripheral infection of mice. Bacteria gets into their brain, causes degeneration, causes cognitive dysfunction, and triggers A-beta, this protein that everyone else has been obsessed with. So to summarize, we think natural aging creates these leakages in the blood-brain barrier. The bacterial load creates leakages in the blood-brain barrier. ApoE4, if you have any genetic risk, it can increase this leakiness, giving some people Alzheimer's disease. Also, what about younger people? What if you had multiple concussions that increase the permeability of your blood-brain barrier? Well, you might end up with dementia in your 20s or 30s, like some of these football players are ending up with. So we're working on a therapeutic. This particular bacteria is quite resistant to broad-spectrum antibiotics. The more we understand about the microbiome, the more we know we don't want to wipe out all these good bacteria. That just clears the way for the pathogens to take over. So we're developing a very narrow-spectrum antibiotic, which also protects the cytotoxicity of the bacteria. And this is a general approach. We're learning more and more about the microbiome. It's hard to discover these bacteria because they have imperfect penetrance. So being infected in one area of your body might be fine. Having a low-level infection might be fine, but having a higher level in a different organ or in your brain clearly could cause more problems. They have a very long life cycle. So these pathogens don't want to kill their host, like Ebola, for example. You don't get infected and then 2 weeks later you have symptoms and you die off. These pathogens are very tricky. They want their host to live a long time. So they can hibernate, they can stay undercover for a long time. So the process of discovering them is going to be more difficult, but I'm really excited about the possibilities it presents.